All right, great. Hello, everyone. Welcome to Boom, Bust, and BS with Anthony Maluski and me, Christian Purefoy. And today we've got two special guests to talk about titanium.
Well, not just titanium. We're going to talk about exploration in Canada and national security. Right? It's always interesting. So, hey guys, I appreciate you guys coming on. Why don't you just tell everyone real quick who you are and what you guys are, who you guys are with?
Yeah, it sounds good. I'll start. So my name is Mike Steer. I'm the CEO and director of Saga Metals Corp.
Yeah, and Michael Garrigan, the geologist for Saga, and yeah.
So I see. I've kind of had a look at your guys' website. Saga has a few different projects, but my understanding is you focus on the titanium part of the exploration portfolio these days. Like, what exactly is titanium? I mean, when I think about titanium, it's like like someone broke their arm or something. They got like a titanium bone in there. But what actually is titanium for?
Yeah, I think that's a good point, is that you're right. It's used as implants, if you need so. I've got an implant, my old hockey injury. I'd have an implant for my front tooth, right? And it's titanium based. And so it's really used in so many facets of our everyday lives that I don't think we've fully grasped it, right? At the end of the day, it's in your iPhone. It's on your walls, right? It's a pigment
Where does it
in
come from?
paint.
Where like right now, if I go in and I get something done or whatever, where is titanium produced today?
So the majority it comes out of China, right? And so, when you mentioned at the beginning of this, the whole national security side of things, over 60% of the world's titanium comes out of China. And so that's kind of the hot topic and big issue right now, is that we need to
Is it
shore up
mined?
more.
Is it mined in China and then
Correct.
China? So the deposits, is there a lot in Africa too, or is that something different? Mineral sands, is
Yeah,
that
no,
titanium?
yeah, there's some that comes out of Africa as well. Russia. Some comes out of Canada right now from Rio Tinto, right? So it does come from all over the world, but it's dominated by China.
And so America, is it safe to say that most of America's titanium is coming from China? Is that fair?
I think that's a fair statement. And again, to come back to the national security side of things, United States is one of the largest manufacturers of titanium metal. So like your end use products that companies like Boeing or Airbus or Lockheed Martin would use, but they don't mine really any titanium. Like they import the majority of their full consumption, right? And
Is
so
titanium
that's
on, do you know, is titanium on any of I know like in the recent months, there's been these sanction lists and critical minerals lists and all this sort of stuff. Do you know, in terms of America, is it on any of those lists?
Absolutely, yeah.
100%. Yeah.
Like, so has China put tariffs on titanium?
Not at this point in time, but it has come up recently as a threat of one potential metal that they would not even just tariff, but potentially cut off the exportation of it to other countries.
And yeah, and it's being used on fighter jet. I mean, America, right? This is literally national defense. Fighter jets are made out of this stuff.
What
Also,
about drones? Do they use titanium in drones? Probably, I would think. Like
Yeah,
exoskeletons, maybe.
it's used in aerospace applications, so it certainly could be. I haven't specifically looked up drones, but it's in airplanes, satellites, spaceships, fighter jets. Lockheed Martin's F-35 Raptor uses 40% structural titanium.
and there's no replacement for titanium
When
in
you said
these.
Raptor, I was thinking about the Ford Raptor. I wonder if there's titanium in cars. Do they put? There must be titanium in automobiles as well, right? Or
Automotive, yep, there are applications as well. Chemical processing. Do either of you guys golf? Right? It's in your
not
tennis.
very well.
It's in your golf clubs. It's also in tennis rackets.
Okay,
Pretty
so
sure.
titanium is kind of like a lot of these, Christian, we're always talking about minor metals and critical minerals, and it's in the same category. So it's sort of the same setup. It's critical to all these military applications. It's used in a bunch of stuff we don't even know it's being used in our golf clubs, and
And
China
there's always
controls.
one problem.
China control. It's back to China. So you guys, so I guess what's interesting, Mike, you guys have a company. It's listed on the TSX, right? Yeah, I think it is.
Correct. TSX Venture, yeah.
And you've got an asset in Canada. And you guys tell me a little bit where you guys are at. You guys have drilled, I know, quite a bit. And what's the size of your titanium deposit today? And like, how does that fit in around like other global deposits and that sort of thing?
Yeah, Mike, if you want to jump in, I'll let you
Yeah, you
kick it
bet.
off.
So yeah, we have done our maiden drill program. I'll probably like correct you a little bit is we haven't done a ton of drilling, but we are
Yeah.
pretty advanced within the project. And this kind of comes back to a big discussion within the junior mining industry in Canada and the critical minerals and everything that we're looking for. Canada and North America has a ton of these, but for a long time, Canadian companies have looked elsewhere around the world. So this is kind of a perfect example is this titanium vanadium deposit that we're looking at
And
is
by the way,
pretty
when
early
I tell you, Mike,
stages.
I just interrupt you. We literally just published on vanadium, what, like
You
a week ago?
did. Yeah,
Yes.
absolutely. And I read that article and I honestly thought it was a brilliant article. And titanium and vanadium, in my opinion, go hand in hand. They are quite often found in not only the same deposits, but often the same minerals, as is the case with our project, is we are getting titanium and vanadium locked up in titanomagnetite.
So when I hear magnetite, and I'm not a geologist, I just play one on TV, I think about iron ore. Is there a
Absolutely.
relationship? Is there a relationship between your deposit and iron ore?
Correct.
Absolutely. You're absolutely right there. Yeah.
Okay, so you're
Interesting.
saying that Canada and North America have got a load of these minerals, but there's been this problem they haven't in mind. Is that changing?
Correct. So, yeah, and it's kind of an interesting discussion. And what Russia and China has done really good at is going at these really large tonnage, layered mafic intrusions, big deposits of
Hey, hold up.
titanium.
I gotta hold you right there. You lost me at layered.
Okay.
What is that? I don't even know what you're talking about. You got to help us out here. So a layered mafic intrusion.
Layered mafic intrusion. And apologies, I didn't mean to get too technical.
No.
But point is they are very big, very large deposits.
So what
And
you're saying is your style of deposit sitting in North America and Canada, potentially the 51st state we've heard, although it's not been confirmed, uh, has this big ore body or this big anomaly. Is it an anomaly right now? And you guys are basically going out and do you have a drilling program lined up or what do you guys have going on?
yeah, absolutely. So we've started to find the shape of the anomalies in the ore body, and we're continuing to do the drilling to essentially try and prove how big this thing actually is. And it very well could be massive, and that's what we're hoping to prove to the markets.
How much are you guys drilling? How many meters do you guys have scheduled?
So the next drill program, we're looking at doing about 10,000 meters. That's going to hit our main targets that will allow us to infer the 20-kilometer trend that we believe is mineralized.
So right now, there's not an inferred resource on the property. It's just you guys are kind of kicking off the drilling program to create one. Is that right?
Absolutely. That's correct. Yeah.
And remind us who else produces titanium in Canada? Does anyone? Rio maybe?
Rio Tinto at the mine Lac Teal in southeastern Quebec, they, as far as I know, are the only big time producers of titanium coming really out of North America outside of your ilmenite sands.
And
There's a
so when you
small one,
produce
sorry, there's a
when
small one
Rio,
in America, right? In Utah or something, I thought. Very small.
They're very well, like there's, I know if you follow the Appalachians down, there, like I think Tennessee has one. There's ilmenite sand deposits, and they're pretty rich in titanium. The problem with those deposits is because they're like a sedimentary sand, essentially a placer deposit. Quite often they're not that big, and that's been the big difference between say China and Russia and what the Western nations have done is we've looked at these placer deposits, if you will, as being easy and cheap to mine, where Russia and China has looked at these great big deposits that yes might take more capital to get it going, but they might have 75, 150-year mine lives.
and a deposit like your guys, and I know it's early, but what order of magnitude of capex is something like this going to require? Is it in the low hundreds of millions, or I mean, I know like who knows, but it seems like it's hard to raise $1 billion today, right? I mean, it's challenging. Uh,
Yeah, I mean, I think for us, and again, like we brought on Paul McQuiggan, he's an expert geologist and metallurgist, and he's confirmed in the zone that we've drilled that we do have simplified metallurgy, right? So because we only have the one mineral magnetite, we can essentially do a crush and magnetic separation of the mineral, pulling out the combination of iron, titanium, and vanadium ore body essentially and then ship that off for processing. So our we would endeavor to keep, any kind of plant or capex to a minimum at our actual site because there's already other facilities around the world, like in Quebec, that already processes titanium, iron, vanadium, those kinds
so
of
would
things.
you
So we
would
don't
you
need to
guys also
reinvent the
be
wheel.
producing? Would you also be producing vanadium and iron ore?
Correct, yes.
Correct. Yeah, it's all byproducts from the same processing methodology.
Interesting. Hmm.
Yeah.
Okay, so what's the next step? So the next step is you guys over the summer, you're going to be drilling. You're out, probably already out there. Are you going to be out there?
Yeah,
And
I'll be out there in the next week actually, so
oh, cool. And then help us out. So how long from when you start drilling until you can start typically announcing how those drill results are going? Is it take a few months, a few weeks, 6 months?
So I mean,
so
yeah, go for it.
so really what you're waiting for is your assays from the laboratory, right? So you're pulling the drill core up, you're doing your descriptions, you're taking your samples. Those samples have to go to the laboratory, and you need that kind of verified laboratory confirmation of what is in that rock to be able to actually release that to the public. We can talk about things like and update the public and the markets and the investors on how the progress is going, but not until you have those concrete laboratory results can we speak to that.
And is it getting busy with gold being where it's at? Is there a lot? I mean, are you feeling like more pressure at the labs just because of all the activity that's going on out there, or not really a factor?
I don't think
Um,
it's a factor. I mean, we've got a good relationship with the lab, and I would actually say the last drill results we got on our first maiden program, like we didn't have to overpay for rushed assays, and they came back in a respectable time period, consistent with a lot of our other programs that were just grab sample programs. Like it all came back fairly in good order. So I'm not expecting any unknown delays or unforeseen delays with other commodities.
Interesting.
So
Uh,
what's changed then in North America to make this viable from what's gone for the last couple of decades to what's happening now?
geopolitics for one, the geopolitical atmosphere, but also the research that has gone into the metallurgy and the recovery of titanium and vanadium from things like magnetite. That's again one of the reasons that North America has looked at these small ilmenite sand projects as being so viable. There was less complications now, but we've actually, and China's led some of the headway with the research on the recovery. It's potentially at a massive turning point where like these big deposits are potentially even more viable, more economically viable than they've ever been before. I've had people reference that it's kind of on, and again, not to get technical, but on the verge of when we worked out the models and the research for copper porphyry deposits. That changed the copper industry for forever, like globally. And it kind of feels like we're on the verge of that.
so what's next steps here? I mean, it seems like for the market, just updating on this drilling program is going to be really, really key to kind of just everything. It sounds like from my perspective. I mean, in addition to the geopolitical environment, which you don't control. I mean, that's just is what it is. But it seems like this drilling program is pretty critical.
Yeah, for sure. And just to back up, 1 second, I think one important factor here is that the maiden drill program that we did sort of confirmed the thesis that not only does this magnetite set below the surface, but it is quite extensive and has the ability to be quite, large across the entire property. And so this is utilizing a combination of grab samples, geophysics, which is essentially utilizing a magnetometer, which detects the magnetic levels coming from underneath the surface, and then using that to drill essentially. So All of that combined is what got us to where we are right now, that has confirmed this 500-meter zone that is quite extensive just within this small zone. We have 19 and a half more kilometers at minimum to go drill, with about 4 immediate priority targets that this summer we're going to be doing that same geophysics on to get that same below the surface 3D, image and anomaly that you can see, so that Mike can take that to delineate, exactly where do we want to put the drills. And then we're going to move that along the property, along the remaining 19 and a half kilometers. So again, this is where when you compare it to other projects, this 20-kilometer inferred zone is unbelievable.
That's pretty cool. So just for the people who aren't mining engineers or even, that close to the industry, I mean, 20 kilometers, I'm just thinking about how long that is. I can't go jog 20 kilometers, let's put it that way. I mean, probably lucky to do 5, but how do you have to put the roads in to get a drilling spot, or is it kind of open? Is it forested? How hard is it to actually get out there and drill this thing?
So
Well,
that's a great point, Mike. If you don't mind, I kind of step in there. Is
yeah.
one of the amazing things about this property is we are 10 kilometers from the coastal town of Cartwright, Labrador. So we have unbelievable infrastructure. Like we have a road that literally takes us about 100 meters from our main mineralized zone. So in other projects where you're expecting heavily forested areas and you're punching big roads in, yes, we are putting roads in to get the drill exactly to where we want it, but it's a matter of a kilometer or two or a mile or two, or a couple hundred meters rather than 10, 15, 20 kilometers. So that is a huge difference and advantage that we have.
Well, and to kind of help people with that, when we say we're going to put a road in from, say, one of the already existing access roads that would come into the property where you would actually drill, we're not talking about your typical road, in your neighborhood. Like, we're not paving this thing, or it doesn't require a whole, extensive amount of work to do it. We're talking about using an excavator to just create a proper, nice, smooth surface so that we can move a drill along, right? So it's a very simplistic process. Doesn't, cost a whole lot to do it, but it's going to be game changing in terms of being able to move that drill along and just keep going along the whole 10,000 meters that we want to do, right?
Well, that's exciting. Well, look, I'm really glad you guys have come on the show and tell us a little bit about titanium. I'd love to have you guys back when some of your results start coming in. Help us kind of understand what the meaning of it is, and maybe come back on and give us an update on the market as things continue to develop inside of the U.S. and Elon and Trump work out their
And
problems.
bromance.
Yeah. So, look, really appreciate it, and thanks a lot for coming in.
Yeah, thanks,
Yeah,
guys. Appreciate you having us on today.
Cheers,
yeah, I really
guys.
appreciate it. Thanks, guys.